forecast control using the tracking signal by the mean absolute deviation and also by looking at the error by the statistical control chart. By the tracking signal method, basically we see whether a forecast is constantly high or constantly low, whether it's predicting more than the demand constantly or less than the demand constantly. So it is a kind of a cumulative effect over time that we can see from the tracking signal developed by the mean absolute deviation. So that's the method number one. And then method number two is this statistical. I wouldn't say they are method one or two, they're more kind of complementary to each other. So one kind of see how it is, what is the cumulative effect over time, whether it's constantly high or constantly low, is there any bias in the forecast. And in a statistical control chart, basically you see how the error is distributed over time. And typically the 3 MAD plus minus is used as a standard, but sometimes it could be plus minus 2 MAD deviation or 4 MAD or up to 5 MAD deviation can be used depending on the data type or product. But a statistical control chart generally plus minus 3 sigma, that's what is used in for a statistical control chart. So I have produced these 4 different tracking signals using the MAD for 4 different forecasting for the exact same data set. If you don't know how to produce this chart, you can check the openeducator.com. I have a video for each of these, how to produce this forecast using Microsoft Excel. In this chart, as you can see here, that the tracking signal telling that the exponential is smoothing with the smoothing constant 0.2 is going outside the plus 3 MAD, and minus 3 is okay. However, this forecast is going over the plus 3 high, meaning that it predicted bias low. So the demand exceeds the forecast consistently. Same for the smoothing constant with the adjusted smoothing, with the smoothing factor or train factor 0.3 and smoothing factor 0.2. It is not doing so great job. On the other hand, you can see the linear trend is doing a little bit better. It's not too biased. The moving average is also towards the bias low situation where demand exceeds the forecast consistently. However, I have just changed this smoothing constant from 0.2 to 0.9, and as you can see that the data immediately predicting well, and even better with the adjusted smoothing, where the smoothing constant is 0.9 and the train factor is 0.3. By that you can see it's doing really well. Probably the best forecasting for this data set if we use adjusted exponential smoothing and smoothing constant 0.9 and the train constant 0.3. So the tracking signal gives you a way of playing with this adjusted constant values and find the best forecasting method for this particular data set. On the other hand, the error that is plotted against 3 standard deviation up, 3 standard deviation down. Again, if you don't know how to produce this chart using Excel, there is a video on that. You can check those out. So this basically all of them are doing fine. I also produce graph with 0.9 smoothing constant. They have very similar like this, and as you can see they're within the control limit, so they wouldn't change much even if you change the smoothing constant. So a statistical control chart here is not really telling much as you got from the tracking signal method by the MAD. So as I said before I started that they're kind of complementary, so we'll have to kind of do both of them to see what is the best way to forecast this particular data set. As you can see here, exponential smoothing, adjusted exponential smoothing is doing much better job than any other method of forecasting. And we know that by doing, when we check the statistical control chart, we also check the tracking signal by the mean absolute deviation. So we applying this both technique, we can see what would be the best way to forecast some data set.